two midterms, then you'll be taking two midterm examinations. So midterm would be as usual would be after 6th week, and then the other midterm would be after 12th week if the instructions come that two midterms will be taken. This is the tentative distribution of marks. 20% for assignment, 30% for midterm, and 50% for final exam. So this 20% can include some quizzes also, maybe of 5 to 10% weightage, and then the other 10% would be allocated for the assignment. I expect that you'll be submitting the assignment which would be given to you on time, and I expect that you'll be doing those assignments by yourself. So just the basic information of system of units is as flashed. Like you should know that how many systems of units are there, and actually these systems of units we shall be using in the applications of this and I call applications as the numerical problems which we shall be solving in the class. So another thing I want to tell you that the numerical problems are actually the applications of the theory we shall be covering in class. So you have to grasp a good understanding of those numerical problems, which reflects the theoretical part, okay, which reflects the application of that theory. So most of the course, it is numerical oriented course. So mostly we shall be doing numerical problems in class, and I'll be needing your support in that regard for the calculations and for different equations. So please be with me so that we can do it together with success. So we shall be using these three system of units in those applications. So you should know about the conversions of the units from remaining in the same system of units. You should you should know that how to change the force unit from kilonewton to newton, and the volume unit from liters to meter cube, and the weight unit from kilonewton to dyne. Okay, so you should be able to convert units keeping remaining in the same system of units, and you should also be able to convert units from one system of units to another system of units. And for your information, there is a chart given in every hydrodynamics of fluid mechanics book at the end or at the start for the convergence factors. So I expect that you would be having at least that chart in front of you while doing numerical problems. And that chart would be available online very easily, the conversion factors. So keep those conversion factors in front of you while doing the applications and numerical problems. In exam, for exam point of view, if you have to convert some system of unit to another system of unit, then I'll be giving you the conversion factor also. But you should be able to do it as quickly as possible. Okay. So you already know that there are fundamental dimensions and there are derived dimensions. Derived dimensions are being derived from the fundamental dimensions, and some number of fundamental dimensions are as flashed. These are the fundamental dimensions, and we shall be using the first four fundamental dimensions in our course. Then there are some derived dimensions. Um there is one topic which is called dimensional analysis. In that topic, you would have to play with the dimensions of some derived quantities, derived dimensions. So for that, it is prerequisite to write the it is prerequisite that you should be able to write the dimensions of every derived dimension quantities. Okay, so for the dimensions, we usually use length, mass, and time. Length as capital L, mass as capital M, time as capital T, and then uh, dimensions can be written for different quantities like this. So you should, if you know the units, you can easily write those dimensions. So there shouldn't be any problem in writing the dimensions. So we shall be using those dimensions in dimensional analysis only. The rest of the course would be independent of these kind of dimensions. Okay. So just you should also know the prefixes. Though we will be using some of the prefixes given here, but you should know that. So these are some a little exercise for the conversion. Uh, Try to do it by yourself. Again, this is another exercise. So I expect that you'll try to convert uh, uh, these units uh, in your free time. That was the basic things which I wanted to discuss with you regarding the units, dimensions. Now, let me tell you about the further details of the course content, and you can check from this presentation. I have planned the course like this. Uh, In the first lecture, we shall be discussing fluid properties. In the second lecture, maybe we will be covering many topics regarding the fluid statics. And you might have known the definition of fluid statics. As the name implies, fluid statics is the study of fluids in stationary conditions. So all the laws which are included in this fluid statics would be discussed in the topics, and the knowledge of fluid statics is very essential prior to the knowledge of fluids which are flowing. Okay, because the bases are the laws of fluid statics. Some of the laws uh, would be applied, some of the laws for the fluid statics would be applied to fluid dynamics and fluid kinematics. So I have used another two terms, which one is fluid kinematics and the other is fluid dynamics. So fluid kinematics uh, include, includes the study of velocity and acceleration of the fluid, kinematics. Fluid dynamics include the study of forces and energies, forces, energies, momentum of the fluid which is flowing. So uh, the hydrodynamics this is the study of all these three uh, parameters, or you can say all these three branches. That is the combination of all these three branches of fluid mechanics. So uh, in fluid statics, we'll try to cover all these topics. Then uh, after fluid statics, we shall be covering. Okay, I think there is one slide missing, which is regarding the fluid dynamics and the other contents of the course. So let me tell you orally without checking the slide. After fluid statics, we shall be covering fluid kinematics, laws of fluid kinematics and fluid dynamics. Actually, we shall be applying the laws of conservation of mass, energy, and momentum, and and the microscopic derivation of those laws, uh, or you can say that differential form of different laws would also be studied. Uh, so if we are going to study the differential form of different laws, then it means that we are we this study is associated with microscopic uh, uh, approach. Okay, so then after applying the laws of fluid kinematics and dynamics, we shall be doing the pipe flow problems, and after discussing the pipe flow design of pipe flow problems, um, flow in the pipelines, then we shall discuss about the flow in open channel. Very less content regarding flow in open channel, since you have uh, uh, already done one course which is related to open channel flow. But just mm, to go with the contents of this course which I have been given, we shall be discussing some topics regarding flow in open channel. Then after doing flow in open channel, we shall be discussing the flow dynamics in hydraulic machinery. Okay, and then finally we shall be discussing the dimension analysis and similitude topics. So that was the introduction of hydrodynamics course. Uh, let's start formally the first topic, uh, which is just before doing the first topic, you should know the branches of fluid mechanics and their definition. We already have discussed it, uh, and you can study it by yourself. So, fluid is the basic definition starts from the definition of fluid, since hydrodynamic is the branch of fluid mechanics. So you should know the concepts of fluid mechanics uh, in it, and and the foremost definition you should know is the definition of fluid. A fluid is a substance that flows under the action of shearing forces. That is, if a fluid is at rest, the forces acting on it are in balance. A fluid can be compressible and can be incompressible. A fluid can be Newtonian and can be non-Newtonian. So let me know about compressible and incompressible. As the name implies, what fluid you will call as compressible? Can anybody tell? Compressible. As
The fluid of which
yes,
we can reduce the volume is compressible fluid.
very good. On applying, on applying, how can you reduce the volume of fluid?
Applying pressure.
On applying pressure, very good. So on applying pressure, if the fluid density changes or volume changes, it means that or there is some volumetric strain is produced, then we say that fluid is compressible. And when that volumetric strain which has been produced on applying pressure is negligible, then fluid would be called as incompressible. Similarly, there is one other definition which is important: Newtonian and non-Newtonian. Viscous stresses that arise from the fluid flow at every point are proportional to local strain rate, the rate of change of its deformation over time. So, according to according to the Newton's law of viscosity, Newtonian fluid is applicable, or Newton law of viscosity is applicable to Newtonian fluid. So, what is Newtonian fluid, or how it is defined? Uh, Newton has performed some experiments, and he just derived the expression of shear stress on fluid, and he says that shear stress is depending upon the viscosity of the fluid and the velocity gradient. Okay, so he has performed this experiment. Now the parameters involved in it, let me tell you, using the simple example. So there are two plates. Okay, one plate one plate is fixed. Okay, and in between these two plates there is a fluid, and the distance between the two plates is y. Okay, so the top plate is moving, but the bottom plate is not moving. There is oil in between. Okay, some oil. So it means this the you if on applying force the top plate would be moving, you are applying shear force on the top plate. Then according to Newton, the force applied to this plate is directly proportional to the area of the plate and the velocity of the top plate. If u is the velocity, then the force is F. F is directly proportional to area, contact area of this plate, A, and velocity of the plate, and it is inversely proportional to the distance between the bottom or boundary. Okay, like it is inversely proportional to, here it is y. Okay, and he observed that on the layers are moving like this. If you apply the force on the top plate, the layers in between the two plates would be the profile of those layers, or you can say velocity profile of those layers. If this is zero line, velocity profile would be like this. Okay, so the maximum velocity would be here. Okay, and this is actually u. So according to Newton, he observed that this force is directly proportional to A, u, and inversely proportional to the distance between the two plates. So on further simplification of this equation, he also said that this u, since this u over y is actually the slope of this velocity gradient, du, we can say that u over y is the slope, which is du over dy. Okay. So again, on rewriting this equation, I'm writing here, F is directly proportional to area and du over dy. Further, on rearranging, we can say that F over A is directly proportional to area and du over dy. Okay, another slide so that I can use those blank slides. So F over A is directly proportional to du over dy. So that was the derivation from the Newton when this was the case, that top plate is moving and bottom plate is fixed, and oil is also stationary. Only uh, the force has been applied on the top plate, and the layers of fluid would have some velocity, and the profile of layers of fluid, velocity profile of the layers of the fluid in between would be like this. So what about F over A? F is actually parallel force, you can see here. So when the force is parallel and divided by area, it becomes stress. So it would be shear stress. Parallel parallel stress is actually shear stress. So we denote shear stress with tau. Tau is proportional to this velocity gradient, the slope of the velocity profile. This is actually slope of the velocity profile. Then again, tau, if you want to change proportionality sign to equality sign, you have to introduce a constant, and that constant here, it is the coefficient of viscosity. So this is actually Newton's law of viscosity, and then he applied the same law to the two different cases, like the two plates are stationary and only fluid is moving in between. So can you give any example of that case, that the two boundaries are stationary and fluid is moving in between those boundaries? What can be the example for that scenario? If you perceive the example of pipeline, in the pipeline the boundaries are fixed but fluid is moving inside. So for that case also, for that scenario he applied the same equation and was successful in proving that shear stress is proportional to the velocity gradient and constant of proportionality is mu. But there are some fluids which do not conform to, or which do not confirm this law, and those fluids would be later on called as non-Newtonian fluids. So when you see this graph, this is the graph between like if you say that, rearranging the same equation, you can say that tau over du over dy should be constant. Okay, so if this ratio is constant, it means that it is a Newtonian fluid, Newtonian fluid. So it means the slope of the graph between shear stress and velocity gradient should be constant, like this. So this straight line reflects the constant slope, and also depicts the Newtonian fluid. And when this slope is not constant and it keeps on changing, it means that it is non-Newtonian. Then there are some other types of solid, which is, one is called ideal plastic and other is called elastic solid. In case of ideal plastic, you can see that initially on applying shear stress, there is no deformation. Actually, this velocity gradient is representing the deformation. Okay, so initially, when applying shear stress for ideal plastic condition, there is no deformation, but at some point, at some threshold value of shear stress, further increasing the shear stress would cause this deformation. Okay, so that is called as ideal plastic, and when there is no deformation, it means that is elastic solid. And when there is only deformation without any shear stress, it means that it's ideal fluid. That for it means that oil or any fluid is uh, uh, oil or fluid is kept on moving without any force application. Okay, so that fluid would be called as ideal fluid. Okay, you don't need any force to flow for an ideal fluid. It keeps on moving. Neither it is resisted by any friction. It just keeps on moving without any resistance. So that is actually the ideal fluid, uh, which is practically not possible. Okay. So this is regarding Newtonian and non-Newtonian fluid. So check some other properties of fluid. Okay, pressure and force. You already know the definition of pressure and force. Pressure P is defined as the amount of force exerted on the unit area. Some units conversion are given. Pressure is basically represented as Newton per meter square or pound per foot square, and it is also represented as in terms of bar. So you can see the conversion of the pressure. Then you should know the definition of density, which is mass per unit volume. You should know the definition of specific weight. Density is represented by rho, and it is mass over volume. Units are given here. Okay, these are the units. Slugs are the unit for mass in British gravitational system. Okay, you should just keep that in mind. Then specific weights. Density is mass per unit volume. Specific weight is weight per unit volume. Okay, and it is represented in kilonewton per meter cube or pound per foot cube in British gravitational system. Kilonewton per meter cube is next slide. Then another term which we shall be using often in our course, which is called specific gravity. Specific gravity is the ratio of weight of a body to the weight of an equal volume of a standard substance. So the standard substance, it is specific gravity is actually the ratio, and it has no unit. Okay, so specific gravity can be defined as the ratio of the densities, two densities, or it can be defined as the ratio of two specific gravities. It can be defined as the ratio of two weights also. So for an equal volume. Okay. So when you and what are the ratios? What is in the denominator and what is in the numerator? In the numerator is the density of the fluid which is under consideration, for which you have to calculate the specific gravity. Okay, and in the denominator there is some standard substance. When we have to find out the specific gravity for liquid, the standard substance would be water, and when we have to find out the specific gravity for the gas, for any gas, fluid can be gas or and a liquid. Okay, if you are to find out the specific gravity for gas, the denominator would be the density of gas at standard temperature, and standard temperature is considered as 4 degrees. Okay, so this is the definition, some of the definitions of properties of fluid. Again, some conversion factors. Then you should clearly know about the concept of viscosity. We have already discussed some concept in the form of Newtonian and non-Newtonian fluid, but some other definitions are given here. The viscosity of a fluid is a measure of its resistance to shear or angular deformation. It is the property of fluid by mixture of which it offers resistance to deformation under the influence of shear forces. It depends upon the cohesion and molecular momentum exchange between the fluid layer. So basically this viscosity parameter is depending upon you can say the shear stress. We already have discussed. Viscosity is depending upon the shear stress. The more you have to apply the shear stress, it means viscosity is more. Or you can say this shear stress is actually depending upon viscosity. Viscosity is the physical property of any fluid, and it is constant for any specific temperature throughout. Okay, so shear stress. If you have to apply more shear stress, then it means that to keep the for one velocity, for specific velocity, if you have to apply more shear stress, it means that this viscosity is more. That is why shear stress has to be greater. Okay, to keep the same velocity of the liquid in between, or the plate moving above the liquid. Okay, so this is how viscosity can be defined, and uh, we'll be discussing this property uh, in many of the fluid flow phenomena. So it is the basic parameter of fluid flow. Okay, so many equations are depending upon this basic property of flow. Let's discuss the Pascal's law. Pascal's law, according to Pascal's law, pressure at any point. Now we are, after discussing some of the properties of fluid, we are moving towards the fluids in fluid statics. So here, the first law of statics have been discussed. Pressure at any point in a fluid is same in all directions when the fluid is at rest. So we are going to derive this law. Let's check its derivation. That how can we prove that the pressure at any point in fluid is same in all directions when the fluid is at rest. So considering a wedge-shaped element like this, okay, uh, and this is the element of fluid which is in stationary condition. So it means that this wedge-shaped element is also in stationary condition. The lengths of the sides are dx base, dy vertical length, dz on the z-axis, and the another dimension which is this hypotenuse dimension, which is length of this wedge shape element. So it is dl. So from here to here it is dl. Okay. So our objective is to prove that pressure on every side would be equal. Like if Px is the pressure on this side, okay. So Px is here. Pressure is actually uh, uh, distributed over the area. So I say that it is Fx. Okay, let me see the nomenclature. Fx1. Okay, and the force on the y-axis due to the pressure would be Fy1. Okay, so pressure, if Fx1 is the force on this side, and Fy1 is the force uh, normal to this side, then what about pressure? Pressure is force per unit area. So Fx1 over, what is pressure? Pressure, how would you define pressure? If I want to find out Px1, so how would you define that Px1? If Fx1 is the force on this side, then it would Fx1 divided by the area, this area, whole area, as the pressure is distributed among in the whole surface, over the whole surface, and we have to prove that Px would be equal to Py, would be equal to Pz, and would be equal to P. Okay, and we shall be deriving proving that using the forces applied on each face of this wedge shape element. So since this wedge shape element is in stationary condition, we are able to uh, use the laws of equilibrium to prove that. And how would we use the laws like this? Summation of, since this wedge shape element is stationary, so we can say that summation of f of x would be equal to 0. And summation of f of x involves many parameters. If Px is the pressure on this surface, then force Fx1 can be calculated using Px and the area, and Px multiplied by the area. So Px multiplied by dz and dy would be the force Fx1, we can say. So this is actually Fx1. This is Fx1. Okay. Then what about this force? This would be P multiplied by d and dz. How would you determine the force on this inclined surface if P is the pressure over here? P is the pressure on this area. So pressure multiplied by area would give you force. P multiplied by dz, the area of this inclined surface is dz multiplied by dl. That is written over here. Pressure multiplied by the area and cos alpha. Why cos alpha? Since this angle is alpha, and you have to consider the x component of this force. Okay, so x component of the force, which is normal to the inclined surface, would be what? Would be cos alpha force. Just check this figure, then you'll understand. So if f, this is f, okay, and this angle is alpha. So what about if this angle is alpha, then this angle would also be alpha. If this is alpha, then this would also be alpha. The angle between the horizontal and the force, which is actually, we call it F, okay, which is the force on the inclined surface. So if this is alpha, then what about the x component of this force? It would be P dl dz cos alpha. So this is the x component of the force. This, okay. So that is why we have used this x component in this summation. Okay. So in order to use this law of equilibrium, you should keep that in mind, that all the forces will be along one direction. So if you are taking x-axis in applying the law, then you have to use the forces in x direction. Then rearranging it and just putting cos alpha as dy by dl. How they have put that? Cos, just check from here. Cos alpha would be, if this is dy and this is dl, then cos alpha can be written as dy by dl. So putting the value of cos alpha here, finally you'll get this equation. Px is equal to P. It means that the pressure on the x-axis is equal to the pressure on the inclined surface. Okay, so this has been proved through the law of equilibrium. First expression for the law of equilibrium is the summation of fx is equal to 0. So then again, using summation of fy is equal to 0, since the wedge shape element is in equilibrium condition. So you can apply the second rule of equilibrium, which is summation of fy is equal to 0. And in this summation, first all the forces along y-axis would be 0. Then how many forces are there in y-axis? One is the force due to the pressure of the fluid below this wedge element, okay, which and that pressure or that force would be normal to the surface of that wedge element, okay, which is this. This is the force. And then the other force would be the weight of this wedge element, which is acting at the centroid of this wedge element, and which is acting downward, vertically downward. So which is called as dW. So these are the two forces along y-axis. The third force would be component of this force along y-axis. Okay, and this component would be P d L d z sine alpha. Okay, so this is the y component, and this y component would be written here. Okay, so just adding all the forces along y-axis, you'll get this equation. Okay, now in this equation, uh, but one parameter is neglected, which is dW. Okay, dW, if you see, how would you calculate weight of this wedge element? Weight is actually equal to gamma multiplied by volume. Gamma is the specific weight, which is the definition of specific weight we just have covered, which is weight per unit volume. So if we know the property specific weight, then we can calculate the weight of any fluid element. Specific weight. Okay. Specific weight multiplied by the volume of this wedge element will give you the weight. Okay. Since this, just keep that in mind. This wedge element is very small and differential element. And if we multiply the specific weight with the volume, and how would you get the volume? Area multiplied by the area of this triangle multiplied by the length of this wedge shape element will give you the volume. Okay, so for that volume calculation, you have to multiply uh, dy multiplied by dx over 2 is the area of this triangle, multiplied by the width of this wedge shape element, which is dz. So this would be the volume of the wedge shape element, dz. Okay, so this is the volume of the wedge shape element multiplied by gamma will give you dw. But since this is the product of three differential dimensions, dy multiplied by dx multiplied by dz, so it would be very small. So the weight of this differential element can be neglected as compared to the pressures, pressure forces applied to the from the side. Okay, so can be can be neglected. So since it is the product of three differential dimensions. So here in the next equation, you can see that dW is being neglected. And you'll get this equation on just expanding the sine alpha into dx by dx. Finally, you get this. Py would be equal to P. So you have proved that Px is equal to P and Py is equal to P. And it means that Px is equal to Py is equal to P. Okay, so this is actually the Pascal's law. It means that pressure applied to any element in a fluid which is in stationary condition is equal in all directions. But that pressure, just remember that pressure would be normal to the surface of that element. Okay? And similarly, you can also prove that Pz is equal to P. Okay? Similarly, by applying the conditions in z direction, it can be proved that Pz is equal to P. Okay, now we are going to discuss another very important law, or you can say that very important concept of the fluid statics. Before discussing that, you should know that how many forces are applied when the fluid is in stationary condition. Or you can say how many forces are applied to the element of fluid which is in stationary condition. So one of the forces which is called as gravity force or body force. So gravity acts on the particle. Gravity doesn't care whether the fluid particle is moving or not. So it is always acting. Okay. The other force is called as pressure force, or it is also surface force. So we have already discussed the pressure force. So whenever the element is in stationary condition, pressure forces would be acting on it. Okay, pressure forces are those forces which are acting on that particular specific element from the peripheral elements of fluid, and those pressure forces would be perpendicular or normal to the surface of that element which is under consideration. Okay, so these are the two forces which are being applied on the fluid which is at rest. Okay, and what about the shear stress? Whether shear stress would be shear force is applied to that fluid which is in stationary condition, or what about the shear force? What is the opinion about the shear force? So when the fluid is at rest, it means there is no shear stress. Okay, just remember that. The fluid which is in stationary condition won't be having any kind of shear stress. Again, one of the very mostly used concept in the fluid law is the one you have used already, which is called as P is equal to gamma multiplied by H. If you want to find out the pressure at any point, you have to know the specific weight multiplied by this depth of that element from the free surface, which is called H. So you already have used this for many cases. P is equal to gamma into H. So how can you prove that? That is, P is equal to gamma H. And sometimes it is also written as P is equal to rho GH, as gamma is rho G. So what is the proof for this? We are going to check that. Okay. How it is proved? So this is actually the variation of pressure in a static fluid. So how pressure varies in a static fluid. As the fluid is at rest, the summation of forces acting on the element in any direction must be zero. The horizontal direction forces are the pressure forces acting normal to the vertical surface of the element. So the forces are in, just consider this cubical differential element. The sides of this differential element is as flashed, like along the x-axis, the size, the width of this cube element is delta x. Along the z-axis, the width is delta z, and along the y-axis, the width is delta y. So this is the cubical element which is under consideration. The weight of this cubical element is acting vertically downward, and we already have discussed that how would you calculate the weight. Weight would be equal to the specific weight multiplied by the volume of this cubical element. So since this fluid element is at rest, so we can apply the laws of equilibrium on this fluid element. And again, how can you get the pressure forces or surface forces? So pressure forces would be, if you know the pressure at the mid of this cubical element. Let's say that pressure here at the midpoint is P. So this is the average pressure, you can say. Assume that the average pressure in the cubical element is P. So if this is the average pressure, how would you determine the pressure on the surface? Okay, so for this you have to check the rate of change of pressure towards the surface and the rate of change of pressure towards the bottom surface, isn't it? So you would have to use that Taylor series expansion for that. This pressure, if you know the pressure gradient, you would be able to get the pressure on the surface. So since you have said that you are assuming that pressure over uh, at the mid is P, or you can say average pressure on this cubical element is P. Okay, so and what about the surface pressure? For that you should know the gradient of pressure towards the surface, above surface and the below surface. Okay, so if we are using the sign convention of the axis, like positive above, pressure above would be positive and pressure below would be negative, then the pressure on the top surface would be P plus gradient. Gradient, what would be the gradient? It would be change in pressure per unit length on a z-axis. So this is written change in pressure per unit change in delta Z. Since we are considering the z-axis only right now, and we have to find out the surface forces, which is pressure force on the surface of this cubical element. So using the convention that pressure increases with increase in distance in the z-axis, P plus, this is pressure gradient, rate of change of pressure in z-axis, multiplied by delta Z by 2. So delta Z by 2 is actually the distance. Gradient multiplied by distance would give you the pressure, delta Z by 2. So this is actually change in pressure. So P plus this change in pressure, total change in pressure, will give you the pressure on the surface here. And pressure multiplied by the area of the top surface is delta X multiplied by delta Y. Okay, this from here to here is delta Y. So this is area, and this whole term is the pressure gradient, pressure change, which is depending upon the pressure gradient, and this is the pressure at the middle. Okay, so pressure change can be determined using the pressure gradient and the distance from the middle. Okay, so this is how you use Taylor series to get any surface pressures. So again, similarly, you can obtain pressure on the bottom surface y minus, because according to our sign convention, uh, or according to the axis, positive axis and positive z-axis, negative and positive z-axis or sign convention, we assume that pressure decreases decrease in distance in in z-axis. So that is why P is the pressure here, and when you have to calculate the pressure at the bottom, you have to do like this. Okay, this is pressure gradient, delta P over delta Z is the pressure gradient, multiply by distance in which this pressure gradient is acting, which is delta Z by 2 again. Then you would have the change in pressure from the mid pressure, from the average pressure. So P minus this change in pressure multiplied by the area of the bottom surface, which is the same with delta X and delta Y, would give you the force. This is actually force. Okay, Fz2, and this is Fz1. So taking summation of all the forces along z-axis, you'll get the final formula. So F summation of F in z-axis would be equal to 1 is the Fz1, which is downward, and we'll say that it is minus Fz1, because according to our convention, downward force is negative. Then Fz2, which is positive, Fz2 plus, sorry, not plus, minus W. W is the weight of this wedge-shaped element, which is gamma multiplied by delta x multiplied by delta y and delta z. Okay, so just expanding all the parameters of this summation that you can. And when you open these brackets, all the other parameters would be cancelled except this delta p over delta z. Or you can say that this delta x and delta y would be cancelled from delta x, delta y, and only delta z would be left. So final, after just simplifying this above equation, you'll get this expression like sorry, this would be partial p over partial v is equal to minus gamma. So this would be left after simplifying this equation. So you may do it by yourself, and then you'll understand it, that how it is simplified to this. Okay, then this is basically through this law that rate of change of pressure in z-axis is equal to negative gamma is giving birth to this law, which is P is equal to rho gh. Okay, we shall be discussing the transformation of this law to this law in the next class. If there is any question regarding today's lecture, please let me know. I'll try to answer. Am I audible? Okay. I'm just discarding the writing, and I'll be uploading the clear presentation for you. But I should be confirmed about that you have registered the course on elements. Okay, so please register for this course on LMS so that I would be able to share the presentation with you, though I can share you in MS Teams also, so I'll be sharing in MS Teams. But you have to register on LMS because I would be taking quizzes on LMS. Okay. So let me, if there is no question, then I should be downloading your attendance. Any question, please let me know.
मैम क्विज़िज एलएमएस पे तो अब तो डीएल नहीं होगा, नेक्स्ट वीक से एफटीएफ में हो जाएगा, तो क्विज़िज तो
हाँ, फिर भी मैं एलएमएस पे लेती हूँ, वो कोई नहीं, आप रजिस्टर कर लें, हम कंप्यूटर लैब में फिर बैठ जाया करेंगे और एलएमएस पे आप क्विज दे सकेंगे।
ठीक है मैम।
तो वो मैं यही चाहती हूँ कि वो ताकि वो फौरन से आपके पास भी रिजल्ट आ जाए और मेरे लिए भी आसानी होती है एलएमएस पे। तो वो
मैम उसके लिए की चाहिए?
हाँ, वो मैं पूछती हूँ एलएमएस कोऑर्डिनेटर से कल। तो मैं मेरा नंबर, एक ग्रुप अपना बेशक बना लें हाइड्रोडायनेमिक्स का, एमएस हाइड्रोडायनेमिक्स, और आपका जो सेशन है 2020, ताकि मैं जो भी इंफॉर्मेशन जो भी होगी वो मैं फिर डायरेक्टली आपको ट्रांसफ़र कर सकूँ। ठीक है, मेरा नंबर नोट कर लें और ग्रुप बना लें कहीं। लेकिन ये है कि आप खुद मैच्योरिटी के साथ मैसेजेस भी करें या कॉल भी करें, तो मैं एक्सपेक्ट करती हूँ आपसे मैच्योरिटी। दैट्स व्हाई आई एम शेयरिंग माय नंबर विद यू। ठीक है, तो मेरा नंबर है 0346-500-1107। तो इस पे आप एक ग्रुप बना लें, मुझे भी ऐड कर दें और मुझे एडमिन राइट्स दे दें काइंडली, ताकि जो भी इंफॉर्मेशन होगी रिगार्डिंग दी कोर्स हाइड्रोडायनेमिक्स वो मैं आपसे शेयर करती जाऊँ। और कई दफ़ा ये होता है कि अगर लेक्चर में कोई चीज़ रह गई है तो मैं व्हाट्सएप के थ्रू जल्दी से वो बता देती हूँ और वो इंफॉर्मेशन शेयर कर देती हूँ, तो मेरे लिए ज़रा
एक्सक्यूज मी मैम, काइंडली नंबर रिपीट कर दीजिएगा।
0346-500-1107। 1107।
ठीक हो गया।
तो वो अपने सारे जो स्टूडेंट्स हैं उस ग्रुप में होने चाहिए, ठीक है, ताकि कोई मिस ना हो और किसी कोई इन्फॉर्मेशन मिस ना हो किसी से। तो और LMS रजिस्टर कर दें प्लीज, ठीक है। So that's all for today. If you would have any question regarding today's lecture, you can always send me a message, or you can email me. I'll try to answer your questions, but maybe I'll be taking some time to answer, but I do try to answer each and every question if you are asking. Okay. Let me download your attendance, and you would be free to use. अच्छा, हमारे अभी जो स्टूडेंट्स जो पार्टिसिपेट कर रहे हैं वो 9 स्टूडेंट्स हैं। तो कितने स्टूडेंट्स ने ये कोर्स रजिस्टर किया है, कुछ पता है?
नहीं मैम कंफर्म तो नहीं है अभी, तो फर्स्ट लेक्चर है सबका।
अच्छा,
वैसे मैम टोटल आई थिंक 20 के आसपास होंगे।
ये तो आज तो बड़े कम है फिर इसका मतलब।
मे बी फर्स्ट लेक्चर है शायद इसलिए।
ओके, थैंक यू सो मच। अल्लाह हाफिज। ईमेल मेरा आपके सामने मैं रख देती हूँ, स्लाइड में मैंने शुरू की
मैम
स्लाइड।
18 ऑनलाइन है, 18 स्टूडेंट्स ऑनलाइन है। एक
कोई स्टूडेंट क्या मतलब क्या?
7
ये इस लिस्ट में सारे नहीं आ रहे? अब तो 8 हो
मैम
गए।
टोटल 17 अवेलेबल हैं जो लेक्चर ले रहे हैं।
अच्छा हाँ ठीक है, वो सब आ गए होंगे फिर पार्टिसिपेंट्स में। +8, अच्छा मुझे ये लग रहा था कि ये टोटल 8 है। ठीक है, दैट्स गुड। वो फिर वो जो मैं डाउनलोड कर रही हूँ अटेंडेंस, उसमें होंगे फिर वो भी। ओके, थैंक यू सो मच। मेरा जो ईमेल एड्रेस है उसमें आई प्रेफर दैट इफ़ यू हैव एनी क्वेरी रिगार्डिंग द लेक्चर्स, ट्राई टू ईमेल मी, ठीक है। ईमेल ईमेल ज़्यादा एक ऐसा मीडिया है कि जो कि मैं बड़ा ऑफन यूज़ करती हूँ, तो वो रिप्लाई करना मेरे लिए आसान होगा वहाँ पे। हाँ, व्हाट्सएप पे भी अगर आप कोई एक सिंपल अगर क्वेश्चन करते हैं तब मैं कर सकती हूँ, लेकिन अगर उसमें डिटेल्स रिक्वायर्ड है तो वो मेरे लिए ज़रा व्हाट्सएप पे मुश्किल हो जाएगा। तो मुझे ईमेल करें अगर कोई भी क्वेश्चन है, तो ये मेरा ईमेल एड्रेस है, ये आप नोट कर लें। ओके, थैंक यू सो मच। अल्लाह हाफिज़।